This is Lesson 2, Section 1.6. I'm going to work through the homework problems from the textbook. And one thing I want to mention as we begin this is we're talking about rational expressions, which is very similar to the concept of a fraction. Basically, a rational expression is a fraction because it's anything that can be written as a polynomial divided by or over a polynomial. And so a couple things we know about fractions: you want to always simplify them. You always want them in simplified form. And so that is also true of rational expressions. In order to add or subtract fractions, remember you have to have a common denominator. We'll find that that's also true with rational expressions. And then also with multiplication and division, you multiply the numerators, multiply the denominators. And honestly, to do this with rational expressions, you have to have the skill or be fairly proficient at factoring. Because one of the first things you want to do, especially with simplification and then multiplication and division, is you want to factor each polynomial. So you need to develop that skill of factoring so that you can do this without too much difficulty. So let's dive right in. The first problem is number 5, and it asks you to simplify the rational expression. That means to divide out any factor or any piece that the polynomials have in common. And so first, you can't just say, okay, I'm going to cancel y squared and y squared, okay, because y squared plus 10y plus 25 is all connected by the plus signs, and it's considered one unit. And you can't just break it apart because you want to. But what we can do is we can factor it into individual pieces. And so I would have y and y, pair of numbers multiplies to 25 and adds to 10. I believe that's 5 and 5. And I want a plus and a plus. In the denominator, I would have y times y. And then I need a pair that multiplies to 30 and adds to 11. I believe that would be 5 and 6. And they both would be positive. And see, then what I notice, once I've divided it up into its individual pieces, notice that I have y plus 5 as a unit in the numerator and the denominator. So they will divide out. Some people say cancel. So that ultimately we have y plus 5 over y plus 6. Now, honestly, guys, this is just like if you had the fraction 3/6 and I asked you to simplify it, most of you know that it would simplify to 1/2. It's the same idea, but we're doing it with polynomials. Okay, the next one, again, is one that we need to factor. Okay, it's a little bit more involved. You may want to go off on some scratch sheet and maybe use the box method. I'm going to use trial and error here. So let's see. I would have 2x times x. And if I put 4 here and 1 plus and minus. Okay, in the denominator, the first thing that I notice is that I have a common factor of 2. So I'm going to take it out. So I'm left with 2x squared plus 1x minus 1. And then I'm going to try to factor that. Okay, so in my numerator, I still have the 2x minus 1 times x plus 4. I have my common factor of 2. And then I'm going to factor the other one. So I have 2x and x, 1 and 1. I need this one to be a plus and this one to be a minus. So that once I get it factored, I notice that I have the unit 2x minus 1 in the numerator and the denominator, so it divides out. So that I have x plus 4 in the numerator over 2 times x plus 1. Looks like my plus sign got messed up there. Let me see if I can fix that for you. There you go. All right, so there's your answer. The Simplified form of that rational expression is x plus 4 over 2 times x plus 1. With multiplying, it's sort of like the simplification process, but you have lots of pieces to deal with. Normally with multiplication, if I wanted to multiply together, say 3/4 times 2/3, there's different ways to do it. We could simply multiply together the numerators. 3 times 2 is 6. 4 times 3 is 12. We get 6/12, and then simplify to 1/2. We can also, if we wanted to, we could simplify the fractions before we actually do the multiplication. And if I do it that way, I would say, okay, I would have a 3 in the numerator and the denominator, which divides out. 2 divides into 2 one time, 2 divides into 4 two times, and then I have 1 over 2. Either way, I get the same answer. So again, you can approach the multiplication either way. I like to simplify it first, especially with the polynomials, because otherwise I just end up with these huge numbers that make it difficult to work. So the first thing that I need to do is factor all 4 polynomials in this multiplication problem. Okay, so I'm going to do that first. So let's see. Need a pair of numbers that multiply to 24 and subtract to 2. 6 and 4 in the denominator. I need a pair of numbers that multiply to 36 and add to 12. I believe that would be 6 and 6. In the second fraction, I need a pair that multiply to 24 and add to 10. Okay, so again, that's going to be 6 and 4, and they're both minus. And then finally, the last one, a pair that multiply to 16 and subtract to 8. Let's see. 1 and 16, 2 and 8, 4 and 4, 4 and 4. No. And 8 and 2. No. I believe I got a typo here. Let's change this problem a little bit. Okay, let's change it to plus 16. Otherwise, it doesn't factor. Okay, so because if I do the plus, just a typo in the problem. Sorry about that. Okay, I would have 4 and 4 plus, whoops, not plus, minus and minus. Okay, I'm getting all messed up here. Let's see. All right. Should be minus and minus. Minus and minus. Now, when you go to simplify, I call the process simplify on the bow tie, because I can divide out anything that is diagonally across from one another or that is vertically across from one another, so that it sort of looks like a bow tie when you're finished in terms of your simplification. So I notice, and I'm going to rewrite this here for a minute so we'll have it. So x plus 6, x minus 4, x plus 6, and x plus 6 times x minus 6, x minus 4, and then x minus 4, x minus 4. Now I'm going to do the simplification. I'm going to divide out the things that I can in the numerator and the denominator. So starting on the top, I have x plus 6 and x plus 6, one in the numerator, one in the denominator. I have x minus 4 diagonally across from x minus 4. I have, on the other diagonal, I don't have anything. I have x minus 4 and x minus 4. So that when I'm finished and I have all of the things divided out, I'm going to end up with x minus 6 all over x plus 6. And one of the reasons you want to multiply them together and then simplify them is because as you progress through the levels of mathematics, dealing with a fraction such as x minus 6 divided by x plus 6 is going to be a whole heck of a lot easier than dealing with the original problem. All right, let's try to do one more multiplication before we end this video. Okay, so again, the first thing I want to do is try to factor all of my polynomials here. So I'm going to set it up. Let's see, I would have 2d times d, and then if I do 5 and 5, they're both positive. In the denominator, I have a difference of 2 squares, so I'm going to have 2d plus 5 and 2d minus 5. In the denominator of the second fraction, I have, again, a difference of 2 squares. It would be 5d plus 1 and 5d minus 1. And let's see, then I have to do the numerator. I would have 2d and d. Again, I have 5 and 5, and they're both going to be minus this time. So again, remember, we're going to cancel on the bow tie, and I'm going to write it down again so you'll have it and can see what I've divided out. Again, I call it simplify on the bow tie because you're doing it in a bow tie shape. Okay. All right, we're almost there. All right, so I'm going to begin and I'm going to cancel on the bow tie. Okay, so diagonally across from one another, I have nothing. On the other diagonal, I have a 2d minus 5 unit that can be divided out. On the vertical, I have 2d plus 5 and 2d plus 5 as a unit that can be divided out. And then on the other vertical, I don't have anything. So ultimately, when I get things divided out, I have, I have d plus 5 times d minus 5 all over 5d plus 1 and 5d minus 1. Now, that's an acceptable answer. In some cases, though, they may go ahead and multiply it back out. Especially if it's multiple choice, you need to be aware that that same answer could be d squared minus 25 over 25d squared minus 1. They're both difference of 2 squares, so I just multiplied them together. Whoops, my 2 disappeared. Okay, so that's multiplication and simplification. And we'll come back in another video and look at division, addition, and subtraction.